So we can, by observation, just count, well, there are 1, 2, 3. There are already 3 leaves. Okay, but if I want to write an algorithm to actually get to this answer, how do I go about doing that? Now, recall, when you're writing a recursive algorithm, you want to have something that stops the recursion, a base case, and you want to have something that keeps the recursion going, or the recursive case. Okay, when it comes to trees, what stops recursion? No children, exactly. Okay, so if you discover you're at a leaf node, then that is a base case. There is no more recursion to do. And then again, the opposite then should hopefully be obvious. You recurse if there are still children to visit. Okay, so if we want to write an algorithm to count the leaves of this particular tree, then, well, our base case kind of writes itself. Okay, so if n is a leaf node, again in Java that would be it has null for both of the children, then we just, whoops, we don't change the color that way. We just then return, well, we find a leaf node, so we return 1. Okay, otherwise, well, we want to add up all the leaves. Okay, so if we need to have a recursive call, we have 2 branches. Okay, so this is one way to think about these kind of recursive algorithms. So we need to investigate the number of leaves on this subtree and the number of leaves in this subtree, and we need to add them together. And it's recursive. We need to do the same thing here. In this particular subtree, we need to add up all the leaves. Okay, so to do this, then we just think about, okay, well, I need to return the leaves of, in this case, B, the left child. Okay, and I need to return the leaves of the right child, and I need to just add those up. Okay, so this will basically give me the sum of leaves. And again, if you draw out the methods, if you call leaves on A, well, what that will do is it's not a leaf itself, so then it will have to recurse. It will call leaves on B plus leaves on C. Okay, this is not a leaf node, so this then has to call leaves on D plus leaves on E. Okay, at this point in time, this is a leaf node, so we get a return 1 here, plus 1. Again, we do 1 plus 1, so that returns 2. I should do this in a different color, actually. And this returns 1, this returns 1, 1 plus 1 is 2, comes back up here. Leaves 1, this is a leaf node, so this is just 1, so we get 1 plus 1, and the answer comes back as 3. Okay, and again, if you notice the very subtle tree of calls forming here, okay, there is a exact replica of the tree in this series of calls. Okay, so hopefully that gives you a rough idea how to start thinking about writing a recursive algorithm. Okay.